Hello everyone, it's a great honor to be here to share with you our group's topic. What is the Mathematica? Software important for teaching and learning mathematics. My name is Hu Jing and another member is Fan Jinyu. Actually, when I first got this topic, I'm very nervous because it's very new to me. Because of this assignment, I tried to register an account and had a first experience of Mathematica, which was a very interesting and unforgettable experience. I'm going to try my best to complete this presentation, and in this progress, I have used some videos to show how I use Mathematica, which I hope will help you to have a relaxing time. Let's start with our contents, where we will take you into the world of Mathematica in these 7 parts. Part 1. What is Mathematica? Mathematica is a general-purpose computing system, and the name Mathematica might imply that it's only used for math, but that's not the case. The platform started out as a system for doing math on computers and evolved into the Wolfram language, which can be used for computing in all languages. Today we will take a tour of Mathematica and learn about its many different uses. The first time you start Mathematica, you begin by creating a notebook, a living computational document that defaults to input and output modes. You type in an input and Mathematica gives you the output. In the second part, let's take a look at key features of Mathematica. The first is symbolic computation, which Mathematica can be used to solve equations, simplify expressions, and manipulate symbolic math. Here's an example given of a calculation in which, first, the results are accurate. Mathematica does not convert fractions to rounded hours. It handles them with infinite precision. Similarly, algebra is not a problem for Mathematica. If you want to solve quadratic equations, you can use the solve function. In addition, we can use Mathematica to calculate calculus, definite integration, and indefinite integration. The next one is data visualization, where Mathematica can create dynamic and interactive graphs, charts, and 3D models. Some examples are given here. For example, in chemistry, we can query the knowledge base to find a specific molecule, such as the caffeine molecule. Once we have the molecule, we can plot it using the molecule plot function. But we are instructed that the molecule is not planar. It exists in 3 dimensions. To get a more realistic imaging of the caffeine molecule, the molecule plot 3D function can be used. And by grabbing the molecule, we can rotate in the 3 dimensions and look at it from different angles. The third is programming functions. Mathematica can be programmed to create custom functions for data processing and analysis. For example, if one wants to automate repetitive calculations or data manipulation by automatically generating a table of squares of positive integers, one can use this function and that is what we will get, like this one. It's also possible to pragmatically create custom charts or plots, even specific line colors, red and blue like this one. The fourth is dynamic interactions. Mathematica's dynamic interactions capabilities, implemented through manipulate dynamic and interactive elements, enable users to adjust parameters in real time and watch results change. For example, with dynamic function plotting, you can enter a function and use sliders to adjust A, B, C to see how the shape of the parabola change. In addition, dynamic geometry can be demonstrated. For example, this function dynamically shows that relationship between the radius and the area of circle. I will show you these two examples in the next videos. The first example is like this one. Here is the second example. In addition to these main features, I have made some surprising discoveries through my studies. Let's explore the other amazing features of Mathematica together in a video.
You can compute with entities from all branches of science. For example, let's request a list of all the planets in our solar system by calling the entity list function for the entity type planet. These rounded rectangles are Mathematica's way to display entities. For programmers, you can think of entities as objects. These entities have a wide variety of properties associated with them. You can see what data is available by using the entity properties function. Here are the properties available for each planet. The sheer volume of research quality data available in Mathematica may feel overwhelming. Luckily, Mathematica has an autocomplete feature to assist you, so you don't have to memorize all the property names. For example, let's request the list of all natural satellites around Jupiter. First, we access the Jupiter entity. Next, enter an open bracket to trigger the autocomplete feature to see all of the properties and their names. If we select the satellites property, then we get a list of Jupiter's satellites. The Wolfram knowledge base is vast and growing. There's financial data, geographic data, particle physics, and much more. Mathematica can also import all types of media, including audio, images, and video. Let's quickly look at how many functions there are that start with the word audio. That's a lot of built-in functions, and you don't have to import anything to use these. When you start Mathematica, these functions are all available. Notice the consistent naming conventions. Earlier, we plotted a function using plot. Then we plotted a molecule using molecule plot. And if you want to visualize the waveform of an audio file, you use audio plot. To demonstrate this, let's import some audio. You don't have to specify what type of data you're importing. Mathematica can usually guess from the file extension or data format. Let's click play for some mood music. Now that we have an audio object, we can plot it using audio plot. You can now look at various properties of this audio file. Audio length gives you the song length in samples. The audio sample rate shows you how many samples per second were stored when recording this music. And if you divide the length by the sample rate, you get the length of the track in seconds, 30 seconds. If you look at the plot, you can see this track is 30 seconds long. There are also functions for working with images. All these audio and image functions can also be used when working with video. After all, a video clip is a sequence of images with a collection of audio tracks.
As I said at the beginning, Mathematica is more than just math. It's much more powerful than we think. Welcome to part 3, Why Mathematica Matters in Education. The first point is interactive learning, which makes math move. Have you ever encountered a situation where the teacher is talking about limits or linear algebra, and the formulas are written all over the blackboards, but we're still confused? This is where Mathematica's dynamic interactive features come in handy. This way of learning not only makes abstract concepts vivid, but also allows students to really participate in learning. The second point is to enhance the problem-solving ability, focus on why. In traditional math, we often get so wrapped up in the calculations that we've got to think about the logic behind them. But Mathematica is like an all-around helper that does the heavy lifting for us, allowing us to focus on what's really important. In addition, Mathematica can help us to explore real-life applications of mathematics, such as simulating the trajectory of through objects, studying the stability of building structure, or even analyzing trends in the stock market. Learning math is no longer an isolated paper exercise, but a window to the real world. The third point is access to advanced tools and exposures to the cutting edge of industry. You may ask, why do math students need industry-level tools? The answer is that Mathematica is more than just an educational software. It's an everyday tool for scientists, engineers, and financial analysis. By learning Mathematica, students get early access to the most advanced methods and technology in the industry. For example, students in a statistics course can use Mathematica to analyze large data sets. Not only can they quickly calculate the mean and the standard deviation, but they can also graph the distribution of the data. Such an ability not only provides a foundation for academic research, but also prepares them for future research and job. The last point, connecting across disciplines make math ubiquitous. Mathematics isn't just math, it's the foundation of physics, engineering, economics, and other disciplines. And Mathematica is a bridge between these disciplines. Imagine writing a few formulas in Mathematica and being able to simulate stock fluctuations. Not only does it make math more fun, but it also shows us that it's as accessible as possible in reality. Mathematica is a doorway to new world of mathematics, and Mathematica make math education less boring and more of a journey of discovery and exploration. The fourth part of use cases in teaching mathematics. First of all, let's think about a question together. As a math teacher or student, What are the most common difficulties we encounter in the classroom and in our studies? Is it complex calculations? Is it abstract concepts? Or is it the difficulty in stimulating students' interest? Don't worry, you can use Mathematica to solve these problems one by one. In this part, I will share with you how Mathematica has revolutionized the teaching of mathematics. First, Mathematica can make abstract concepts visible and tangible in the classroom. For example, we can demonstrate this when we learning about limits. By adjusting the range of the slider, students can observe the change of the function in real time, not only limits, but also complex surfaces in three-dimensional space. Mathematica can help us show them dynamically. Next, we talk about student projects. Math projects are a great way to foster creative thinking, but traditional computational tools limit the breadth of the exploration. Mathematica opens up the possibilities. Students can use Mathematica to analyze weather data, study financial models, and even simulating physical phenomena. Here is how to use Mathematica to calculate and demonstrate the displacement of an object in free fall over time. These projects, instead of being simple calculations, are tools for them to explore the world. Next up is the use of Mathematica in math assignments. In the past, when we wrote homework, we might need to draw the images of functions and calculate the solutions to equations, which were time-consuming and error-prone to be manually. But now, by writing dynamic notebook in Mathematica, students record their thoughts and progress while solving problems. When teacher assign an assignment like this one, find the roots of the foundation and verify it with an image. Students can quickly solve the encode and then plot an image like this one. By looking at the intersections of the roots of the curve, students not only complete the assignment but also gain a deeper understanding of the properties of polynomials. Finally, let's talk about exam and assessments. Mathematica provides interactive questions designed to make the assessment process smart and efficient. During the exam, students can drag slides to adjust parameters and observe the changes in the results. This real-time feedback exam format not only tests students' knowledge, but also stimulates them to thinking further about the question. Mathematica is more than just a tool. It's a wizard for classroom presentation, an adventure partner for students' projects, a powerful assistant in homework, and an intelligent referee for exam assistant. It transforms mathematics into a dynamic and creative world. Mathematics teaching from now on is no longer just about imparting knowledge, but about guiding students to explore, think, and create. Let's use Mathematica to brighten up every lesson. That's all my presentation. Thank you for your listening and watching. Let's welcome
this member. Hello everyone, my name is Fanjing and my English name is Helen. You can also call me Helen. Since my group member has introduced the first four parts of our topic, they are what is mathematics, key features of mathematics, why mathematics matters in education, and she also uses cases in teaching mathematics. And I will introduce the following four parts of our topic. There are use cases in learning mathematics, benefits for teachers, and challenges and considerations. Finally, I will make a brief conclusion of what we have talked about today about our topic. And let's move on. Okay, let's turn to the fifth part of our topic, use cases in learning mathematics. The first one is modeling and solution of real problems. Mathematics is well suited for mathematical modeling to solve real-world problems. For example, students can use it to model and optimize various problems, thereby applying abstract mathematical concepts to real-world scenarios. The first one is population growth models. Students can use mathematics to model population growth, set growth rates, and observe long-term trends. The second one is traffic flow optimization. Students can model traffic flow and optimize traffic light times through mathematics. So this is all about the first point. And then mathematical experiments and explorations. Mathematics provides a flexible platform in which students can freely explore mathematical laws and conduct experimental learning. There are also two examples to explain these points. The first one is the behavior of sequences, and then geometric explanation. The first one, students can generate and observe the behavior of Fibonacci or other recursive sequences and study their growth patterns. And about the geometric exploration, verify and Pythagorean theorem or the golden section by manipulating geometric figures. And then the third one is interdisciplinary integration. Mathematics can also help students apply mathematical knowledge to physics, economics, and other subjects, demonstrating the powerful tool of mathematics in different fields. First of all, optimization problem in economy. Optimization problem of the relationship between commodity price and supply and demand, and then kinematics in physics, calculating and visualizing parabolic motion pairs with mathematics, and then through the above use cases, mathematics is not only a computational tool, it can also help students intuitively understand mathematical principles, explore mathematical laws, and solve practical problems. The application of this tool makes mathematics learning more interesting, practical, and efficient. So this is all about the fifth part. And let's move to the benefits for teachers. Actually, mathematics is good to the both teachers and students. There I just talk about the benefits for teachers. The first one is support personalized teaching. Mathematics provides a flexible computing and programming environment that allows teachers to design customized teaching content and exercises for students at different levels. For example, hierarchical practice design. You can design problems from simple to complex according to the student's ability level, such as from basic algebraic operations to higher order differential equation solving. And inquiry learning activities. Students are programmed to complete experimental tasks in mathematics, such as testing some number theory conjecture or simulating the distribution of random events. And second, enhance disciplinary teaching ability. The power of mathematics makes it easy for teachers to apply math knowledge to other subjects such as physics, economics, and computer science. It can help students understand the broad use of math. For example, when teaching harmonic vibration in physics, teachers can use mathematics to show the motion, trajectory, and energy distribution of simple harmonic oscillators. And the second one is the data analysis course. Using mathematics to analyze statistics and draw graphs to help students learn how to solve real-world problems with math. And then third, promote teacher professional development. Using mathematics not only helps teachers impart knowledge, but also promotes their own academic research and technical development and improves their teaching skills. For example, a research aid. Teachers can use mathematics for mathematical modeling or to verify mathematical derivations in academic research. And then it can also save teaching preparation time. And this point, I think it is very important for both for the teachers and the students. Through mathematics, we can save a lot of time because mathematics can make the task very quick. And a mathematics extensive math library and computational capabilities allow teachers to quickly generate teaching materials and solutions to improve lesson preparation. And normally, through the mathematics, it gives a very good examples for students to do exercises. So I think it is very good. And then, for example, I can give all of you guys a example. Teachers can use mathematics to randomly generate a set of exercises that meet the teaching objectives and automatically provide answer analysis. And using mathematics reporting function, it can quickly generate high-quality courseware containing graphs and formulas. And then the seventh part is about challenges and considerations. The first one is the learning curve, requires time and effort to master the Wolfram language and its advanced features. Researchers and advanced students may find it is essential, but also users may be discouraged by the effort needed to become proficient. And secondly, cost. License fees may be a barrier for individuals or institutions with limited budgets. Free or lower cost alternatives like Python with libraries like Number, PY, SCI, and other are often chosen by users who prioritize the budget over mathematical unique capabilities. And then hardware requirements, optimal performance needs adequate computational resources. Finally, specialized usage may not be necessary for basic tasks, making it less appealing for core users. And then we come to the final part, conclusion. I have pointed out some key findings of our topic. The first one is for contribution to teaching. It becomes more efficient teaching methods, support personalized teaching, and help teachers adjust the curriculum content according to students' needs. And the second one is improvement in learning. Stimulate students' interest in mathematics and help them better understand abstract concepts through visual tools. And it can also improve students' ability to solve practical problems. And it can also make an improvement for teaching interaction. The classroom is more interactive, and the students can participate more actively through exploratory learning. And then it can also influence in educational practice, promote the cultivation of critical thinking and creative thinking, improve students' ability to apply interdisciplinary problems, support students' technical adaptability in the future careers. And the third part is about the research limitations and challenges. Technical ability. Some teachers and students are not familiar with mathematical operation, and the learning curve is steep. And the resource allocation. Economically disadvantaged schools may not be able to afford mathematical-related equipment and the licensing costs. And finally, scope of application. Mathematics may be limited in certain age groups or students with a weak foundation. And finally, it's about the suggestions. We can develop an educational version of mathematics that is easier to use and suitable for the foundation level. And we can also integrate mathematics with other educational technologies such as AI and virtual reality to enhance teaching effectiveness and explore its application value in multidisciplinary and cross-field education. And this is all for our group's topic. Thanks for your listening.